Hello, in this short video I'm going to solve the following A-level problem. Tangent to the curve y equals to 3 to the x at the point T with coordinates 2 and 9 makes a triangle with the coordinate axes. Determine the exact area of this triangle. Pause the video at this point and give it a try. Okay, in order to help myself to understand the problem better, it would be a good idea if I sketch what is going on paper. Okay, so let us say that I did this. Here, as you see, I have sketched the graph of y equals to 3 to the x, and then this point 2 and 9 is indeed on the curve. Why? Because if you replace x with the x coordinate, 3 to the 2 becomes 9, which is exactly the y coordinate. So this point definitely lies on the curve, and I am drawing this tangent line at that point to the curve. And then as you see, this tangent line intersects the x-axis at this point and intersects the y-axis at this point, and then makes a triangle with the coordinate axes. We are supposed to calculate the exact value of the area of this triangle. Okay, so it is a very easy problem. So you understand that probably you need to know this length, you need to know this length, and then multiply and then divide them by 2. This gives me the area of this right angle triangle. So in order to find these distances, or the lengths to be better said, I have to know the equation of this line, which is the tangent line to the curve. So what should I do? The function y equals to 3x, I differentiate my function. This is a simple rule, so it becomes the function repeats itself, and then I have to multiply it by the ln of the base. And now the k value of my tangent is y prime calculated at the x coordinate of the point of tangency, which in this case is 2. So the answer becomes 3 to the 2 ln of 3, and this is just 9 ln of 3. Okay, what is the equation? The equation is y minus y naught. This is the equation of the tangent line, k of tangent times x minus x naught. Okay, y minus y naught is the y coordinate of the point of tangency, equals to k value, I just got it, it is 9 times ln of 3, and x minus x naught is the x coordinate of the point of tangency. Okay, and because we want to find the exact value of the area, you shouldn't use calculator to approximate this number. You have to start working with this number 9 ln of 3 itself. Okay, so let me simplify this. This becomes y minus 9. Here, I multiply this number inside. So this becomes 9 ln of 3 times x minus, I multiply this inside, so it becomes minus 18 ln of 3. And what I will do now, I will move this 9 to the other side, so it becomes positive 9. So this gives me that y equals to 9 ln of 3x plus 9 minus 18 ln of 3. Okay, so now you know this is the m value. Okay, so if you compare it with the standard line equation kx plus m, this is k value and this is m value. And of course you can immediately see this m value is negative. Why is that? Because m value is 9 minus 18 ln of 3. You don't need calculator. So if I factor a 9 out, it becomes 1 minus 2 ln of 3. Okay, so now because 3 is bigger than e, because we know that e is 2.7, so 3 is bigger than e, so then it means that ln of 3 is bigger than ln of e, but ln of e is 1. So ln of 3 is a number bigger than 1. So when you multiply it by 2, it definitely becomes bigger than 1 again, so this difference is negative. Okay, but you know that this m value is the y-intercept. What does it mean? It means that if you go here, this point has coordinates. Of course, the x-coordinate is 0 because it is on the y-axis, and the y-coordinate is the m value, yes, which I have written it here. But according to this analysis, m value is negative. but you want to find the length. So what is the length? The length is the absolute value of the m value. Okay, so if I want to find this length, so let me call it, for example, from here to here L1. L1 is not exactly m. L1 is absolute value of m, which becomes the other way around number. So it becomes 9 times 2 ln of 3 minus 1. Yes? So this is your L1. But now I want to find L2. In order to find L2, which is here, I have to calculate the x-intercept. To calculate the x-intercept, you know that you have to put y equal to 0 and calculate the other value, the x value. So if I put y equals to 0 in this equation, I will get 9 ln of 3x plus 9 minus 18 ln of 3 equals to 0. I am looking for x, so I have to isolate my x. So x 9 ln of 3 times x becomes, I move everything else to the other side, so it becomes 18 ln of 3 minus 9. So to isolate x, I have to divide by the coefficient of x. On the right hand side, there are two terms to be divided. 18 ln of 3 should be divided by 9 ln of 3, minus 9 should be divided by 9 ln of 3. Yes? But let me do some simplifications. This ln of 3, that ln of 3 are gone. 9 to 9 one times, 18 to 9 two times, and here 9 to 9 one times, 9 to 9 one time. So it is much simpler now. So it becomes 2 minus 1 over ln of 3. So this is the x-intercept. But this number is positive. Why? Because as I told you before, ln of 3 is greater than 1. So 1 divided by a number greater than 1 is less than 1. So 2 minus that 1 is definitely positive. So it can play the role of L2 exactly. So this means that my L2 is 2 minus 1 over ln of 3. Okay, so now the area is 1 over 2 L1 times L2. So this becomes 1 over 2 L1. What was L1? L1 is just this number, 9 2 ln of 3 minus 1, and then I multiplied by L2, which is 2 minus 1 over ln of 3. Okay? Yeah, there is nothing we can do more. So if you want, you can write it as 9 over 2 ln of 3 minus 1, and then 2 minus 1 over ln of 3. Okay, so this is the answer to this problem. Of course, this is not wanted to use GeoGebra in any ways, but I want to show you how you can solve this problem completely using GeoGebra. Okay, so let us first type the number that I got here. So the number, as you see, is 9 over 2, and then in front of it I open a pair of brackets, 2 times ln. Ln, you can find it under this menu, ln, and then that is ln of 3, and then I go outside minus 1, and then I go outside, open a pair of brackets, 2 minus 1 over ln, again this button 3. Yes, so then you see that this is the approximate value of the number, okay, up to 1 decimal place. So now let me see that how GeoGebra can help me to solve this problem completely, but if you don't mind, let me get rid of this so that you can see the whole GeoGebra here. Okay, so now I will ask GeoGebra to draw the graph of the function for me, y equals to 3 to the x, and this green curve is this function. I press enter, then I find the point of tangency, which was 2 and 9. Yes, do you remember? You cannot see it, so because it is out of reach, t is here. If you don't mind, let me squeeze it a little bit so that it become be at reach here. So that is, yeah, that is good. And then I go to this menu, I use tangent, I click on the curve, it highlights the curve, I click on this point, it gives me this tangent line. And as you see, the tangent line intersects the x-axis at point here, at somewhere here, and y here. Okay, now I want to find those points. So I go to GeoGebra, I choose this intersect, I click on the tangent line, I click on the x-axis, then I have my intersection with the x-axis. I do the same thing, the line and the y-axis. This is the B. Now this is the triangle that we want to find this area. So I go here, I choose polygon, it's a triangle. I click here on point A, I go to the origin, yes, and then from the origin go to point B, but you see it is coming with you. You have to close it by going back to your original point, and this is your triangle. And now if you go under this menu, you see the area. So you choose area and then go on the triangle and highlight it. This is the area 5.9. So this is solving this problem using GeoGebra from scratch, and this is based on my calculation. Do you remember this is the exact value, and this is the approximate value based on my calculation, and this is the approximate value completely using GeoGebra, okay, from scratch. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.